Hello everyone. We have just studied that to remove an electron from an atom, energy is required, and this is known as the ionization potential. Similarly, when an extra electron is added to an atom, energy released, and this released energy is known as the electron affinity. So my dear children, what do you understand by electron affinity? It is the energy released when an extra electron is added to an isolated gaseous atom, and unit for the electron affinity is kilojoule per mole. Electron affinity depend upon two factors: number one, size, and number two, nuclear charge. So how it depend upon size? Let's study. So it depend upon the size. Smaller the size, greater will be the electron affinity. Why it will happen so? Because if the size is smaller, the effective nuclear force on the electron increases. How it become possible? Okay, the nuclear charge attract the incoming electron with the greater force. Why it will attract with the greater force? Because the distance between the nucleus and the incoming electron due to its small size decreases, and due to the decrease in distance, effective nuclear charge become greater. So the incoming electron attracted with the greater force, so more energy it will release. In the similar way, when the nuclear charge become greater the nuclear charge, greater will be the electron affinity. How? In the similar manner, if this is nuclear charge is greater, what will happen? It will attract the incoming electron with the greater force, and when it will be attracted with the greater force, it will release more and more amount of energy. So with the increase in nuclear charge, electron affinity also increase. Now we will study about the trends of ionization electron affinity in a periodic table. As we go along the period, electron affinity increases. Why it increases along the period? Because as we go along the period, size becomes smaller and the incoming electron will be attracted with the greater force, so more and more amount of energy will be released. As we go down the group, what will happen? Atomic size increases. Due to the increase in atomic size, effective nuclear force become smaller and electron affinity decreases as we go down the group. Some important point we need to study about the electron affinity. Inert gases have zero electron affinity. Why they have zero electron affinity? They have zero electron affinity because they do not have tendency to accept electron, means don't accept incoming electron. Why will they not accept the incoming electron? Because they have their outermost shell complete, so they will not accept the electron. That's why inert gases have. Second point, children, as we go down the group, electron affinity decreases. Same will happen in case of halogen. So we can say fluorine electron affinity will be greater than chlorine, but it is not so. It is an exceptional case. Fluorine electron affinity is always less than the chlorine. What is the reason behind this one, children? The size of fluorine is very small, and the electron present in the outermost shell of fluorine repel each other as well as the incoming electron, so they will not accept the incoming electron easily, so their electron affinity is smaller. But in case of chlorine, there is no such repulsive force between the incoming electron and the electron present in the outermost shell of chlorine, so it easily accepts the electron and large amount of energy is released. So chlorine electron affinity is greater as compared to fluorine.